All right, Kay, you got to clue me in. What does HBY mean? Not much. Oh, how about you? I figured it out. I'm amazing. Ridvige, you still playing? I forget every time what it is. It's Rainbow Six, Kill 'Em All, something like that.
He's in the middle of a match right now, so.
He looks it. He looks like he's fighting hard. Got the body language going in there. Cedar, how you doing? All right. Let's see. Got 20 participants. All right, we're almost there. Almost time. We're almost done. You guys realize that? We got today and next week. And then the final exam. Min Sung, why is your camera not on? Is your room a mess?
Yep.
Spike the bullet. Let us see your smiling face. Come on. It's America. We'd like to see your face. There you go. That's what I'm talking about. How you doing?
Good.
Yeah? Sammy, how you doing?
I'm doing good. How about you?
I've got to try this again. How you doing?
I'm doing fine.
There you go. Oh, everybody's showing up. Let's see. Samuel's here. Nick's here. Kay is here. Daniela. You still hanging out with Andrew, Daniela?
Sometimes.
Distantly? How do you maintain 6 feet from your boyfriend? Is that even working?
Nah, it's not working.
That's funny. That's funny. What about you, Anthony? Are you maintaining your distance from Sarah?
Yeah, sort of.
Sort of. Yeah, she's probably sitting right next to you right now. That's why you don't have the camera on.
How you know?
I don't know. I just had a feeling. I sensed powerful sensations going on there. Alec,
You know too much.
what's that?
I said you know too much.
I don't know. I should assume better things, right? I shouldn't assume the worst from you guys. Chris, did you break your new glasses yet again? The second pair of new glasses?
Actually, my brother broke them. We were playing basketball and he broke them.
Was he wearing them?
No, he smacked them across my face.
That's crazy. But you got 2 pair, right?
Yeah, so I'm already using my last pair now.
Welcome to my childhood, man. It would always tape or some glue or something. I broke every single pair.
Yeah, I tried bending them back. Didn't work out though.
Just snapped them in half, or yeah.
Yeah, just like the actual glasses, just straight up bent.
And the crazy part is they're so expensive. I'm like, how can you charge $600 for this or whatever I paid? That's just like,
I think it was pretty cheap. I got them both for $70. So.
Oh, all right, that's not bad.
Yeah, it's pretty good.
Bad at all. Not bad at all. Raul, you out there? Trying to see. 1, 2, 3, 4, 5. Nope, he's not here. Raul's not there. Nick, what are you doing? Nicholas.
Sure.
What's going on in your world?
Nothing. He's hanging out with my mom.
Just hanging out, huh? How are your other
Yeah.
classes going?
This is my own class. So it's,
This is your only class?
yeah.
Oh, it's your class.
Wow, you better be getting an A then. That's all I got to say.
Yes, sir.
That's funny. All right, it's 5:30. So you guys have an exam on Thursday. Hopefully you've been working homework and you looked at some of that stuff I posted. So we'll start. Hopefully I don't have to cover any new material. We'll start with questions you guys might have. Does anybody have any questions? Of the 26 of you present so far, no questions? It's that easy? You're all good at dot structures, you're all good at configurations, you're all good at stoichiometry, you're all good at
Actually, is there something you can go over?
pardon? I didn't hear the question.
On that huge packet that you gave us,
Yeah.
Can you go over the gas stoichiometry practice sheet?
Sure, let me pull that up. Wrong class, sorry, that's not me.
Yeah, that was one of the parts of the sheet that didn't have an answer key.
Oh, interesting. I thought I tried to put answers for everything, but maybe I didn't. Okay, let me share my screen. All right, can you guys see my screen? Yes? Okay. Combined gas law, Boyle's law. So those were the answers. These, I apologize, these questions had the answers right at the end. They weren't a separate set of questions, so hopefully that didn't. Combined gas laws, gas stoichiometry. Oh, they had some answers.
Yeah, the answer key's on there, but just not the work.
Okay. Right, let me share this with my iPad, and then I can see if I can do that.
And then, Professor, quick question regarding the exam.
Yep.
Is the exam on Thursday at 5:30, and then
it is? Yep.
5:30?
Everything's will be just like the last quiz. So I'll post it, and then you can either print it and write on it, or you can type on it, or you can do whatever method that you did last time that worked, or write the answers on a separate sheet of paper and send me the PDF. Anything that works for you.
All right, sounds good. Thank you.
Okay, let me cancel. Let me not share my screen anymore because I'm not able to do this with my screen being shared. All right. Why is this not letting me? You know what? I'm just going to have to do it this way. There we go. Let me airdrop this to my iPad. Accept that. Loadability. No import.
Hi, Professor. Sorry to interrupt.
There is no interrupting. You're welcome.
Professor, so next Thursday is the last class?
Yeah, that is the last day of classes next Thursday. May 7th, May 8th is officially the last day of classes.
Okay.
But I'm still going to be available that following Tuesday to answer questions.
Okay. Just because I was told to be online until the 15th, that was the official.
Well, yeah, right. Well, because the exam is the 14th, so I'm guessing you probably want to be available for that.
Okay.
Right, so that's the exam week, so you need to be available for Raylene.
Yes.
I'll open up class on that Tuesday, although I can't. So that would be Tuesday, the 12th.
Mm-hmm.
I'll open up a Zoom session, but I can't, it's not a normal class, so I can't expect anyone to show up.
Yeah, as long as I can log in and
Yep.
Yeah. Okay.
Absolutely. Make sure. Hey, did you ever hear back from that test you took?
Yes, and I did not pass.
What?
I
I'm
know.
sorry. I don't.
I know. I missed it by a couple points. I just get very nervous. But I'm gonna try again in a month.
Good.
So
Good. Congrats. And you got to. Don't ever give up on that.
I won't. I won't. It's my passion. Thank you, Professor,
right.
for asking.
Sure. Okay. So share screen, iPad. All right. Can you guys see my iPad now? Boom.
Yep.
All right. So let me just start at the top here. Since we're going through this, wait, let me see. There's some chats going on. I want to make sure I see that. I don't see it now. It's not letting me see the chat anymore. All right. Unfortunately, I can't seem to see the box that describes the chat. That's weird. Oh, here we go. No, that's not it.
나 가끔 빨래하다 보면 있어.
No.
해도 나오고 뭐 언제서 다 나와. 양말에도 나오고.
I know there was some chatting going on, but now I, for some reason, can't
다시
see it.
빨아보니까 뺏겨서 이게 묻어가지고 가끔 조금 이렇게 불편해가지고 이렇게 빼면 이렇게 쭉 나오고 눈하고 쭉 나와. 내가 어이씨 이게 왜 이런 데 있어.
Sung, you gotta mute yourself. All right, let me get rid of that. Why is this being weird? Okay. Did anyone have any questions on this first page? Because you got to speak up. For some reason, I can't see the chat box. I don't know what happened to it.
Professor?
Yeah.
So for all these like Boyle's laws problems and Charles and stuff like that,
Right.
do these all have to be in liters and ATM and then Kelvin?
Yeah. If you're going to use, no, let me actually, that's a good question. So let me show you an example. The only time you have to be in the proper units, well, I don't want to just say no. So let's just think about, these gas laws. So essentially the combination of these laws looks like this. P1 V1 over T1 equals P2 V2 over T2. And I'm not going to ask you to say, oh, this is Boyle's law, this is Charles' law, whatever. What you have to think about is these laws give you relationships, right? Anytime you pick two things, those are the only two you have to worry about, right? So if I picked P1, T1, P2, T2, if nothing happens to V, I can just ignore it. Or, you know, I could put V1 and T1 and V2 and T2, no problem, right? However, what you have to understand is that pressure and volume, all right? Pressure and volume are absolute, right? So 0 in any unit means nothing when you're talking about pressure. 0 in volume means nothing when you're talking about volume. So the volume and pressure units doesn't matter what units you're in. But when you say temperature equals 0, that's the one that's a problem, right? Because when temperature is 0, and we're talking about 0 degrees Celsius, that's a big difference than 0 Kelvin, right? And so when you're using this expression, right, because you're putting in a temperature, it makes a difference whether you're talking about a temperature in Kelvin or Celsius, right? So you want to make sure that you're using the right units for temperature. The other ones, not so much. If you're using the ideal gas law, right, same story. This has units, and you have to use whatever units R is, right? So R is going to be 0.08206 liter atmospheres per mole dot K. So you have to be in those units, otherwise you're going to get the wrong answer. So it's
an idea we have to.
Yeah, you would want to make sure that you do that, right? When you're doing these ratios, everything will be fine as long as temperature, right? So you always want to convert it to Kelvin for the temperature, because if you put 0 there, that's going to be a problem, right? You can see mathematically putting a 0 on the bottom of that equation gives you an undefined quantity. So it will not work if you go from like 0 to 50, right? So you have to be in absolute temperatures for that. Okay. Otherwise, you can use whatever. And the thing to keep in mind is that, you know, a lot of questions might give you units And in order for you to use this equation, you're going to have to convert them. So that's something, again, that's kind of brewed into the question, right? So I'm not going to tell you convert this to liters or do whatever. There's just the assumption that you've been practicing enough of those problems, right?
But I know to convert it. Okay.
Right, yeah.
All right. Thank you.
Okay.
Yeah, clear things up.
Okay, so they had the answers for these guys. If there's no super big questions, I'll leave those. But the stoichiometry ones, I think, are probably a little more complicated. Okay. So for the reaction, this reaction written here, so we'll look at, I don't like that color. Why did I pick it? For some reason, I like this purpley color. For the reaction, 2H2 plus O2 goes to 2H2O. How many liters of water can be made from 5 liters of oxygen and excess hydrogen? Okay, so this question is interesting because you're dealing with gases, right? These are all gases, and they're not specifying anything else, right? Normally when you deal with gases, you need to know temperature, you need to know pressure, la, la, la. So first of all, if they're not telling you those values, one of two scenarios exists. You're either at STP, or the second scenario, it doesn't matter, all right? Those are the two possibilities that you're going to run into for this. So when I see a question like this, I see, okay, how many liters of water can be made from 5 liters of oxygen and excess hydrogen? So this is what I'm given. That's what I'm going to start with. I'm going to start with 5 liters of oxygen, okay? Now, the question that you have to ask yourself is, what do these numbers mean in front of these things in the balanced equation, right? I know that certainly they mean moles, 2 moles of this, 1 mole of this, 2 moles of that, right? But do they mean anything else? Well, do they mean...
Ratio?
Pardon?
Is it a ratio?
Yeah, it means a ratio, right? 2 moles of this to 1 mole of that. But can you use any other units for those guys, right? Can you use grams as 2 grams of hydrogen, 1 gram of oxygen, and 2 grams of water? Can't use grams, right? Because grams are different for every species, right? These specifically are counting numbers, so we have to be in something that counts, that are units, right? So I know that those numbers represent moles, right? What you may or may not remember is that, 1 mole of any gas has the same number of particles. So 2 moles of hydrogen, 1 mole of oxygen, 2 moles of water. These things also mean moles of gases. They can also mean the same volume, right? That volume of that particular gas, right? If you don't believe that, right, here's how I would solve this particular problem, right? I know that I've got 5 liters of oxygen. It doesn't give me a temperature and a pressure. So I got to scratch my head and say, well, if it didn't give it to me, A, I either don't need it, or I just assume everything's at STP. You can do that either way, right? If you assume it's at STP, you can convert liters to moles by simply saying 1 mole of oxygen is 22.4 liters of oxygen, right? That's a conversion that we know that's true for any gas. Then you can say 1 mole of oxygen is 2 moles of water. And this is a gas, so I can say 1 mole of water is 22 point, oh, if I did that first one wrong, nobody caught it. Did anybody, nobody even said anything. My units didn't cancel here.
I did, but you skipped me.
You didn't say it loud enough.
Sorry.
All right. 22.4 liters of oxygen is 1 mole of oxygen, right? Now, those of you who are paying attention, you'll see that this cancels with that. Do I even need to do that? So the conclusion you can make from that is if everything in the balanced equation is gases, these numbers represent moles, but they also represent liters of gas, right? So that's a pretty convenient thing we could do for this particular question. So if you look at this, it's 5 times 1 times 2 times 22.4 divided by 22. So it's just 5 times 2, which is 10, which is the answer they gave us, right? So it's a pretty straightforward question. And there's there's that depth to it, right? Where you're going to say, if everything's gases, then those numbers also represent volumes. If that's a stretch for you, don't worry about it. Just do it the way I did it, and you'll get the right answer in the end. Okay, how many liters of water can be made from 55 grams of oxygen and an excess of hydrogen? Again, notice they're saying excess, so you don't have to worry about hydrogen at all. 55 grams of oxygen gas, well, we have to change that to moles. So 55 grams of oxygen gas. I know that 1 mole of O2 gas, and again, moles and grams, I have to go to the periodic table. That's going to be 32.00 grams of O2 gas. Remember, oxygen is 16, so O2 is 32. And then 1 mole of O2 gas from up here. There's 1 mole of oxygen for every 2 moles of water. 2 moles of H2O. And STP, well, that relationship, 22.4 liters per mole, that's true at STP. That's the standard molar volume at STP. So I can say that 1 mole of H2O is 22.4 liters of H2O. So we could do this 55 times 2 times 22.4. I'm going to get my calculator out and just plug those numbers in. So I've got 55 divided by 32 times 2 times 22.4, and I get 77. That's the answer that was posted here. Okay. There's another way to do this. If you forgot about this step, right? If you just go to this part here, you're going to end up with what units? You're going to end up with moles of water. And then what you could do is you could just say PV equals nRT, PV over RT equals N, right? Well, excuse me, I don't want N. I want to solve for volume. Come on, eraser. So I know that that's true. If I solve up to here, I just go that far and get an answer, my answer will be in moles of hydrogen, moles of water. I don't know what that number is. I can find it out. If I want to solve for volume of hydrogen, volume of water, then V equals nRT over P. So I could just plug that volume in there. R is a constant. They told me I was at STP. I could have just plugged those numbers in for standard temperature and pressure and calculated the volume. You would have gotten the same answer as 77. And the reason for that is if you plug STP into this, you get 22.4 liters. 1 mole is 22.4 liters at STP. So this is kind of an easy shortcut conversion, this last step right there.
I got a question.
Yep.
So I'm kind of confused for the first question. You're supposed to be left with water, right? H2O.
Yep.
But when I crossed it out, I just got O2 left over.
Did I do this upside down again? Oh, you know why? Because I'm just really having a hard time writing my answers today. So 1 mole of water is 22.4 liters of water.
Oh, okay. I was wondering what it was.
Yeah, that was just like total faux pas on my part.
And then underneath that, that's H2O as well, right?
Yeah, 1 mole. 1 mole of any gas is 22.4 liters of that gas, right? Maybe I don't have enough sugar. Maybe I need to eat some more chocolate. Something's going wrong in my brain.
Professor, I have a question.
Mm-hmm.
What does it mean when it say excess of hydrogen?
Sure. So normally when you run this reaction, you've got 2 reactants, right? You've got hydrogen and oxygen. They're saying you got 55 grams of oxygen and enough hydrogen to react with that. So we don't have to worry about how much hydrogen is in there. They're just saying only focus on this number. That's really what it's saying, is just use this number. Because in real life, I could give you a problem that said, suppose you have 55 grams of oxygen, and let's make up a number, 32 grams of hydrogen. right? Then this becomes an excess limiting problem. You got to start with this number and calculate water. You got to start with this number and calculate water. And then remember how to pick the right answer. This is going to give a value. This is going to give a value. Which one of those is right? You guys remember excess limiting?
The smaller one?
The smaller one, right? So when they tell you that you have an excess of the other one, what it's really saying is don't worry about the other one, right? You have enough to use all of this up and you don't have to do any extra math, right? On the exam, I'm just going to say you have 55 grams of oxygen and 32 grams of hydrogen. How many liters of water can be prepared? That's how I would specify it, right? So then you got to scratch your head and say, oh my, I got to do the stoichiometry. So I got to write the balanced equation. I got to start with this one and see how much water it'll make. I got to do this one and see how much water it will make. And then I got to pick the smaller of the two and say that's my answer. So it's a little bit more complicated, but that's why you're doing lots of practice, right? This worksheet is practice to help you get good at the individual stoichiometry steps. The exam is going to assess your ability to put everything together in the bigger picture. Does that make sense, Sammy?
Yes, thank you.
Okay. What about this next one? Oh, sorry, I got to erase all this stuff. Come on, go away. All right, how many liters of water can be made? All right, so now it's this question, but it's at a different temperature and pressure. So now we actually have to do that, all right? So we'll have to say 55 grams of O2. 30.
Professor, we can't see the screen.
You can't see the screen?
Just scroll a little bit down.
Okay. Can you see it now?
Yeah, that's good. Thank you.
Okay. Sorry about that. Thanks for letting me know. 32.00 grams of O2 is 1 mole of O2. The balanced equation says 1 mole of O2 is 2 moles of hydrogen, 2 moles of water, sorry. So I'm going to get an answer here. I'm going to get my answer in moles of water. Now, I know I told you I never want an answer in moles, but because I'm at some temperature and pressure other than STP, I have to take this answer and then plug it into the ideal gas equation. So I have to solve at this point midway. So 55 divided by 32 times 2 is 3.4375. 3.4375 moles of water are produced, okay? And then I have to do what I said earlier, PV equals nRT. I want to know what the volume is. So that's going to be equal to nRT over P. So volume is going to equal, let me scroll up a little. I feel like I'm near the bottom of the page. N, that's my number of moles from the previous step, 3.4375 moles. R is still 0.08206 liter atmospheres per mole. Okay. Temperature is 85 degrees Celsius. Can I use that number?
No.
Got to change it to Kelvin, right?
Yep.
So that's 331 Kelvin. And then the pressure, what did they say the pressure was? I got to go back. The pressure is 12.4 atmospheres. Can I use that number in my equation?
Yes.
Yes, because it's the right unit. So 12 over 12.4 ATM. All right, so now I just got to do this math. 3.4375 times 0.08206 times 331 divided by 12.4. Uh-oh, that doesn't look right. Oh, that's because I'm looking at that answer. Let me do it again. 3.4375 times 0.08206 times 331 divided by 12.4. I should have 3 sig figs, and I get 7.53 liters of H2O. And they said the answer was 8.15. Interesting. How many liters can be made from 55 grams of oxygen? That's how many moles there are. Let me double check my math, because I don't know what I did wrong. The other way we could do it is we can get the answer from the previous question and change it from STP to these temperature and pressure, but that just seems weird, but let me do it again. 55 divided by 32 times 2 is 3.4375. That's N times 0.08206 times, let me check, 85 plus 273 divided by 12.4, 8.15. I don't know. I got the right answer this time, so I'm not sure what I did wrong. I did get 8.15. But I didn't put 331 in. I just did the math. Let me see if I did that wrong. 85 plus 273. Yep. I sometimes don't know what I'm doing here. This is 358. See, if you were working these along with me, you could point out my mistakes in real time. Blame it on the calculator. All right. Okay, what about this last one? Here we go. This is a real life question. 34 grams of oxygen and 6 grams of hydrogen. How much water can you make? So this is the kind of question that you might actually run into in real life. So let me copy this question, but not the answer. All right, let me copy this. Let me create a new thing. I'm not sure how this is going to work. Oh, it's going to want to copy. No, stop. How do I paste? Oh, look at that, paste. It didn't do what I wanted. Sorry about that. All right, let me go back to that other note and try to remember the numbers. Chem3 practice. 34 grams of oxygen and 6 grams of hydrogen. I'm trying to find a place to work this problem without having to resort to erasing that answer from the previous one. 35 grams of, it's weird why it didn't copy that. You know, I wonder, no, 35, 34 and 6. All right, so let me go here. 34 grams of O2, 6 grams of H2, STP, okay, at STP, and it was H2 plus O2 produces H2O, and we had 2H2 plus O2 goes to 2H2O. This is gas, gas, gas. Okay, so let's say you get this question, right? And this should be kind of a red flag to you. When you see a question and it gives you amounts of more than one substance, you should immediately think excess limiting. All right. So there's two reactants in this thing, and the question gave you amounts of both of them. So that has to be an excess limiting problem. So as I mentioned earlier, what you have to do is you have to start with each of these and see how much product you make. Now, I believe the question still asked for liters of water. So we're still trying to find out how many liters of water we can make. Apologize. So I'm just going to start with this. I'm going to say I have 6 grams of H2O. I know that 1 mole of H2O, 6 grams of H2, 6 grams of H2, 1 mole of H2 is 2 grams of H2. That's actually, you know what, I should be more conscientious. 2.00 grams of H2. The balanced equation says 2 moles of H2 for every 2 moles of H2O. And because we're at STP, I can say 1 mole of H2O is 22.4 liters of H2O. That's going to give me some number. Right? I also have to do the exact same math with oxygen. 34 grams of O2. 1 mole of O2 is 32.00 grams of O2. There is 1 mole of O2 for every 2 moles of H2O. And 1 mole of H2O is 22.4 liters of H2O. Right, so I'm going to get my calculator out and do the math on the top. I have 6 divided by 2 times 22.4. That's going to be 67.2 liters of H2O. And then 34 divided by 32 times 2 times 22.4 is 47.6. Sorry about that. 40. That's not going to be happy there. And let me scroll my page up just a little bit. 47.6 liters of H2O. So at this point now, I make a decision. Those are my two numbers. I can see that this is smaller than this, so this is the right answer, right? So that's the answer. That means this is limiting. This is excess, right? So all those answers came from doing that simple little bit of math, okay? If I go back to the question, it said, what is the limiting reactant for this reaction? So we count the limiting, we found how much could be produced. There is another question that you might get asked. Can somebody think about what one more question might be asked pertaining to excess limiting? So we found out how much product we could make. We found out which is the limiting, so that's going to get all used up. What's one other question you might get asked?
Is it how much is the excess?
How much excess is left over, right? So that's another question that you might get. How do we figure out how much excess is left over? Well, there's a couple ways to do this. To find out how much excess is left over. In this particular case, because we were finding our answer in liters and we started with grams, it's not a simple subtraction, right? Usually when you're asked to find out how much excess is left over, what I recommend is you start with the limiting reagent and figure out how much of the excess reagent you actually have to use. So I would say, okay, if I start with 34 grams of O2, 1 mole of O2 is 32.00 grams of O2. From the balanced equation, I know that there are 1 mole of O2 for every 2 moles of H2. And again, where did that come from? 1 mole of O2 for every 2 moles of H2. It's from the balanced equation. So I just went to the balanced equation and got that ratio. And then I know that 1 mole of H2 is 2 grams of H2. So what this is doing, what this work right here is doing is saying how many grams of H2 are needed to completely react with 34.0 grams of oxygen. That's what I'm calculating, right? Because once I know how many grams I need, and here I have how many grams I was given, it's just a matter of subtraction to find out how much is left over, right? So let's do the math. 34 divided by 32 times 2 times 2 is 3.75. So this math tells me I need 3.75 grams of hydrogen to react with 34 grams of oxygen. You could have done this, by the way, at the beginning and said, wait a minute, I need 3.75, I was given 6. Oh, hydrogen's the excess. So there are multiple ways to do this problem. But now finally, if you were given 6.00 grams of H2, you used 3.75 grams of H2. Excess is just do the math and subtract those. So 6.00 minus 3.75 is 2.25 grams of H2 extra or left over, right? If I were you, I wouldn't spend a lot of time trying to figure out lots of fancy ways to do this. I would find a straightforward method that works for you and then stick with that particular problem. Okay, does that make sense?
Yes.
So what you just showed us, was that like if the questions were like, oh, you're given this and they use this, what is your excess?
Yep.
Oh, okay.
That would have worked. And typically we'll ask that. All right. Why am I getting picked up twice here? Is my iPad picking me up? Oh, that was kind of weird. Typically the question will ask that. It will ask, what's the excess? What's the limiting? How much product is produced? And how much of the excess is left over? Those are the 4 questions you would typically encounter in a question like that. And I probably, again, you know my feelings on asking the same question 5 different ways. I don't want to ask the same question a bunch of different ways because either you mastered it and you're going to get it right all the 5 different ways, or you didn't master it and I'm punishing you 5 times for not learning one topic. So this has been a blend of a number of different kinds of things we learned, right? There's balancing equations, there's naming involved in that, there's stoichiometry involved in that, there's excess limiting, there's gas laws. I'm going to try to not ask the same question twice. It might turn out that, you know, I inadvertently ask you an excess limiting question twice, maybe once involving grams and once involving gases, those sorts of things. But it's not my goal to ask you the same question 5 different times. This would be a pretty long question, right? Because I probably wouldn't give you the balanced equation either. I might just say, you know, gaseous hydrogen reacts with gaseous oxygen to form water vapor, right? So then you'd have to write the balanced equation and you'd have to balance it. So you'd have to write the balanced equation, you'd have to balance it, then you would do some math involved based on that particular question, right? So while the exam might not have a bazillion questions, some questions would carry a lot of weight because they'd be asking you a number of different things. And I don't feel bad about that because in real life, that's just the way it is. Questions have multiple parts.
So, Dr. Hartmann.
Yep.
So like from the previous one, so like 2.25 gram of hydrogen is left, and 3.75 gram of hydrogen is used.
Let me go back and see what we had.
What
yes.
is left is
Yep, that's correct.
2.25,
2.25 grams were extra and 3.75 were used. Yes.
Okay, thank you.
Sure. And that better add up to 6, however much we were given, right? Because we did a subtraction to get that number.
Yeah.
Okay. That stoichiometry map, that only happened to be part of there. I don't expect you to memorize any of that. Okay, what about the rest of these? Were there any questions on the rest of these stoichiometry type questions?
Can you go to the next? Yeah. So number 2 on that one.
Number 2, the one with acetylene?
Next page.
The next page. Number 2, the balancing, that one?
Yes.
So just number 2, or you specifically?
Just number 2.
Just number 2. Okay. So this one right here?
Yes.
Okay. Well, let's look at that one then, all right? So we need to balance that equation. So when I see that particular equation, the problem with this equation is that oxygen is here and oxygen is split up between 2 other things. And so that's going to pose a problem because this has got a 2. So no matter what number I put here, this is always going to be an even number of oxygens on this side. This has got an odd number here, so I'm going to have to make that an even number. So more than likely, I'm going to balance the hydrogen first, and hopefully that'll take care of it. There are 10 hydrogens here, so I'm going to put a 5 there. So that gives me 5 times 2 is 10, all right? I can already see that maybe this is going to be a problem because that's still an odd number of oxygens, right? And I'm never going to get an odd number with this, and this is always going to be an even number with whatever I end up doing over there. So I already have a feeling that might pose a problem, but let's just go ahead and see what happens as I go through that. I'm not saying that's right, but this is how I would do it. I would look at this and say, oh, hydrogen, I put a 5 there to try to balance that hydrogen. There's 6 carbons here. There's only 1 carbon there. So what if I put a 6 there? What does that do for me? Let's see, 6 carbons, that's good. 10 hydrogens, that's good. 6 times 2 is 12 oxygens there, plus 5. I have 17 oxygens on this side, which would mean this number would have to be 17 halves. That's not a legitimate way normally to balance equations, but if you use fractions, it really is right. I wouldn't worry about that. But the only way to get rid of that is to just double everything, right? So in order to make that a true balanced equation, what this would have to be is this would have to be a 2. This would have to be, let me erase this. This isn't going to be 17 halves. That's going to be 34. This is going to be 12. And this is going to be 10. And first of all, I would look at this. Wait a minute, 34, I apologize, I made a mistake. That's 17, not 34. 17 halves times 2 is 17, not 34. Now I can't reduce this anymore, right? But I'm going to double check. So 2 times 6 is 12, there's 12 carbons. 2 times 10 is 20, 10 times 2 is 20. 17 times 2 is 34. 12 times 2 is 24, plus 10 is 34. So I have the right number of everybody on both sides. So that's how I would balance that. But if you had put 17 halves here and had everything 1, 17 halves, 6, and 5, it's really a right ratio. And I'd be hard pressed not to accept that. It just doesn't look pretty. Okay. Were there any other ones in the balancing equations you guys wanted to go through, 1 through 5?
That was the only one I was stuck on.
Does that make sense, Marlo?
Yeah, I have a different way of doing it, so it would have took me forever to reach 17.
Ah, yeah. Okay. Well, hopefully I don't give you one like that on the exam, right? I'll try not to.
Yeah, it's just that the numbers kept getting bigger than usual, so I don't know if I was going the right way or not.
Yeah, well, honestly, a balanced equation can be balanced even if it's not reduced to the smallest whole number fraction, right? So if you had gotten if you had gotten 4, 34, 24, 20, that's still balanced equation. It really, it wouldn't make a lot of difference to me if you did math with that, because your ratios would still work out in the end. So whatever method you're using, yeah, that method might have taken you a while to get to the right answer, but hopefully you'd still end up with the right answer in the end. It might just take you a little longer. So any of these other ones, anyone want to balance? Anyone want to go through those?
Can we go through the stoichiometric calculations 2A?
So is that on a previous page?
Yeah, I think so. The one before that.
2A. Okay, sure. All right, so acetylene gas, C2H2, undergoes combustion. Sorry about that. Undergoes combustion to form carbon dioxide and water when it is used in an oxyacetylene torch for welding. Balance the reaction and answer the following questions. Okay, so the first thing we got to do is balance it. And it's probably going to be a similar kind of thing where we did that a minute ago. So we'll just start. I've got 2 carbons here, so I'm going to put a 2 in front of that. 2 hydrogens, so that's good. Here I've got 2 times 2, I've got 4 oxygens plus 1 oxygen. So I have 5 oxygens on the right, so 5 halves is balanced. It's not pretty. All right, let me pick another color. We'll pick red and we'll do the other way to balance this. So the other way to balance it would be 2, 5, 4, 2, right? So 2C2, 8C2, my pen, 2C2H2 plus 5O2 goes to 4CO2 plus 2H2O. 4 carbons, 2 times 4 is 8 hydrogens. 2 times 2 is 4, sorry. 2 times 2 is 4, 4 hydrogens. 5 times 2 is 10 oxygens. 4 times 2 is 8, plus 2 is 10. So this is balanced. This is balanced. It shouldn't make any difference which one we use, okay? So we're starting with 113 grams of acetylene, and we want to know how many grams of water. So it's grams to grams, so that should be 3 steps. 113 grams of C2H2. 1 mole of C2H2. I'm going to do this in my head. Carbon is 12, so 12 times, well, 12 point, so carbon is 12.011, so 12.01. Now for the sake of ease of doing this, I'm just going to round in my head. So 12 times 2 is 24, plus 2 is 26. So this is 26 grams of C2H2. When you have your periodic table, use the sig figs from the periodic table. So that gets me to moles of acetylene. We want to know water. So the balanced equation says there are, well, it could be 1 of this to 1 of this, or 2 to 2, right? It doesn't matter which expression you use. Here it's 1 to 1. Here it's 2 to 2. 2 to 2 is still 1 to 1. So 2 moles of C2H2 for every 2 moles of H2O. And then 1 mole of H2O is 18 grams of H2O. So let's go ahead and do the math here. 113 divided by 26 times 2 divided by 2 times 18. And my calculator didn't like that. 113 divided by 26 times 18 is 78.23. 78.23 grams of water can be produced. Okay. How many grams of acetylene react? Right. I'm never going to ask you this question because you don't measure moles. You just don't. Right. I'd be more inclined to give you a question of, what is this in terms of grams of carbon dioxide? So I might say, how many grams of acetylene react if, what is that, 1.10? So carbon dioxide's got a molar mass of 44. So 44 times 1.10 is 48.4. So my question might say 48.4 grams of CO2 are produced. All right, so you would have to say 48.4 grams of CO2. There is 1 mole of CO2 for every 44 grams of CO2. The balanced equation says 4 mole of CO2 for every 5, excuse me, we want to go to acetylene. For every 2 moles of acetylene, and every 1 mole of acetylene is, what do we say, 26 grams of C2H2. So we do the math there, 48.4 divided by 44 times 2 divided by 4 times 26, it's 14.3. Okay, so it's just a matter of, I mean, this kind of fits the pattern I've mentioned a bunch of times. When in doubt, convert to moles. That's what your first step typically does. And anytime you're given grams and asked for grams, it's more than likely going to be a 3-step problem. So there's that. Were there any other questions?
I have one more question.
Yep.
So if you go down.
Yep.
So if you go down to the ionic and net ionic problems,
yep.
number 4.
Okay.
When I was doing that one, I was looking at the solubilities of common salts to see if it was soluble. And the calcium chromate says it's soluble, but on the chart it's saying that it's solid.
Calcium chromate says it's soluble?
Well, according to the answer key, it is, and it's aqueous. And on the chart,
that's not true. That's a mistake.
Okay, yeah, because on the chart I saw a little asterisk to it, so I don't know if it was.
Well, it might be slightly soluble at high temperatures, right? But I mean, again, you're not going to be asked to memorize the solubility guidelines, and I'm not going to try to throw you any curveballs. So certainly remember, anytime you combine a group 1 metal, it's going to be soluble. So anything combined with potassium is soluble. So potassium chromate, so K2CrO4 is going to be aqueous, guaranteed.
Wait, did I say potassium?
Are we working the same question, number 4?
Oh yeah, no. I will say, like, once you get to the
to the other side. Yeah. I'm just starting here with the left-hand side.
Okay.
And then calcium chloride. So remember, the chlorides were almost all soluble except for a few exceptions like lead, mercury, and I forgot what the other one, but calcium chloride is soluble, right? So I would expect you to write something like this: K2CrO4 AQ plus CaCl2 AQ produces, now you got to swap places, so KCl and CaCrO4. And again, why is K2 here and K1 here? Well, because potassium's +1, chlorine's -1. So this tests your naming and formula writing abilities. Calcium's +2, chromate is -2. So that's the correct formula for that guy. It's got group 1, so this is aqueous always. Group 2 tends to be insoluble. Chromates are pretty much always insoluble. So this guy is definitely a solid. No way calcium chromate is soluble. So this is what I would have predicted would be the precipitate. All right, and then it's just a matter of breaking apart everything that's ionic and then writing the net ionic. So for the net ionic, I would put, well, let's just balance it first. So there has to be, let me pick another color to balance it in. So 2 potassiums here, that's to be a 2 there. 2 potassiums, 1 chromate, 1 chromate, 1 calcium, 1 calcium, 2 chloride, 2 chloride. So it's balanced by just by putting a 2 in front of KCl. And then we can break apart everything that's ionic. So 2K plus AQ plus CrO4 minus 2AQ plus Ca plus 2 aqueous plus 2Cl minus aqueous. And then that goes to 2K plus aqueous plus 2Cl minus aqueous plus CaCrO4. Oh, sorry about that. CrO4 solid. And then the net ionic is just after you cross out everything that's the same. So here's a K plus, here's a K plus, here's the Cl minus, here's a Cl minus. So then the net ionic would just be Ca plus 2 aqueous plus CrO4 minus 2 aqueous goes to CaCrO4 solid. I know when I wrote it, this was first and this was second, but I swapped them here. Doesn't matter. I just do it because I know I'm gonna write the calcium first, so I just wrote it that way for my benefit. So yeah, hopefully the things I ask you on the exam will be much clearer. There won't be some susceptibility there. I'm pretty sure that chromate wasn't on the list of things I gave you, but keep in mind that I'm just going to assume that when you're working on the exam, you're going to look up solubility guidelines. You're not going to memorize any of that sort of thing. And so if for some reason you look up something funky and I mark it wrong, just, hey, I looked this up and it said it was soluble, and I'll have to give you credit for it.
Okay.
Other questions?
I have a question about the same problem.
Okay.
When you were doing the double replacement, and you were doing K and Cl minus, what happened to the 2 when it was K2?
Okay. Well, the reason it was K2 up here is because this compound is a compound of potassium and chromate, right? Potassium is a +1 ion and chromate is a -2 ion. So when they form a compound, the right formula for the compound is K2CrO4. When they trade places, potassium is still +1, and over here it combines with a -1 species, so the formula is KCl. The fact that this was 2 out here comes into play when I balance it. I have to put a 2 out front, right? So it comes out in the wash when you balance the equation. But this 2 is a result of the fact that this guy is a -2 ion, and I need 2 of these to balance that charge. When it combines with chloride, that's a -1 ion. I only need 1 of them. So it's really useful if you think you're going to make a mistake like that to write out the word equation. And so I would recommend potassium chromate and calcium chloride produces potassium chloride and calcium chromate. I would write the words out first and then write the formula based on these word equations. Don't worry about what it looked like on the left. Just write it based on the naming skills that you learned. That will hopefully help you avoid writing KCl as K2Cl or K2Cl2, which it's not. Does that make sense, Sarah?
Yeah. So it's kind of like we just kind of don't mind it yet until we balance it.
Don't worry about it. Yep. Just write the names on the right-hand side. So switch the ions and write the names for what you get. And then based on this name, write the formula. Based on this name, write the formula.
Oh, like chromate. That's why
exactly.
Oh, okay.
Absolutely. All right, hold on 1 second. My computer for some reason is not charging, so I'm gonna have to check out and see what's going on. Oh, that's why I'm not plugged in. Give me 1 second. There we go. Oh, my computer would have crashed and we would have been out of luck. Oh, you can see that I'm wearing short pants. All right, were there other questions?
Actually, I have one.
Okay, Min-Sung, what's on your mind?
So from the double replacement reaction, after they react, there is like salt, and there's like aqueous product, right?
Yep.
So like, how do I know which one is salt and which one is aqueous? Do I have to check solubility chart or?
Absolutely, that is the only way to know, Minsung.
So that's the only way. There's no
The
other way
only
I can
way,
do it.
unless you memorize every compound, which I'm guessing you don't want to do.
Okay.
Yep, you have to look up the solubility guidelines. I would guess, after a long time, you assimilate them. They just get in your brain. But I don't expect you guys to work that many problems that you remember. I would suspect, and I would hope, that even though you think something's soluble, you would still double check, right? Because you're going to have all those resources at your fingertips when you're taking the exam. So if you think something's soluble and you're like, okay, I'm going to do this, and then just double check, look it up and see if it's soluble or not. Because it would be silly to make a mistake if you got those resources available to you.
Okay, got it. Thank you.
Sure. Other questions?
I got one more if nobody.
All right. Oh, I'm here for you.
You go down to 11.
11. I can go down to 11.
I'm pretty sure you might have covered this already, but
don't worry. Number
here
11.
It says, okay, so for 11, it just says silver nitrate, and number 13, it says nickel nitrate. How do you know whether it's a 2?
Oh. How do you know if it's a 2 or if it's a 1? Well, silver is typically always +1. So, I mean, that's the most common one. Nickel's one of those funny guys that could be multiples. You don't know. You absolutely don't know. And I would have to tell you. So if that was an exam question, you would have to stop and say, hey, Dr. Hartmann, is this nickel 2 or is this some other version of nickel? It's nickel 2. That's the most common one. And it's silver 1.
Okay, sounds good. Yeah, because I had to look at the answer key and see what it was.
And that makes perfectly good sense. It wasn't a very well-worded question. I pulled some things from practice, and I probably should have looked through them a little better. But honestly, I prefer it this way where you guys come up with some questions like that because other people might be thinking about that same thing. Other questions?
That's as far as I got.
All right. Well, it's 6:30. I don't really want to start covering any new stuff. I think you guys have enough to study. And
Professor Hartmann.
Yeah, Chris.
The day on the exam, are we going to be checking in on Zoom, or are you going to be available for like questions?
I'll be here the whole time, the whole Zoom. So come at 5:30 like a normal class. We'll check in. I'll post the exam. You guys can download it and get work, and I'll just keep my screen open the whole time to answer questions.
Awesome. Thank you.
And I'm available, right? You guys still have my cell number if you want to text or if you want to call. Send me an email if you have some questions. I'll be here for you to answer anything between now and then.
Thank you.
You guys good with that?
Yep.
Any other questions? I'm looking at the chat.
Well, I got one.
Okay.
So for the periodic trends, like what generally, like how's it going to be like for the exam?
Just like a multiple choice kind of question where it'll give you like it might say arrange the following in order of increasing size, or it might say arrange the following in order of increasing ionization energy, something like that. I'm more than likely to ask you those questions, multiple choice. I might ask you a short answer kind of question to say, okay, explain in terms of this why ionization energy increases from left to right, or why ionization energy decreases as you go down, right? So there'll be two kinds of questions, multiple choice where I ask you to range things, and then short answer where I ask you to explain something.
Okay, that makes sense.
Okay.
And then one more, sorry. How many questions are on the exam?
I haven't written it yet, so I cannot say.
Oh, okay.
But Raylene, it will be exactly the same as last time. I will post it. You can download it and print it if you have that opportunity, or you can just look at it and write your answers on a sheet of paper, or you can do it electronically. The only thing I'm going to ask is that everybody try to somehow get me a PDF back. And if you can't, whatever, I'll figure it out. It just, you know, I'll put the onus on me to figure out how to grade them, but it'll be the exact same as the quiz was last time. So is that okay, Raylene? Sounds good. All right, are we all good? Specifically, I do not have an official office hour posted, but if you email me, I will be more than happy to answer your questions. And if you want, we can just schedule a Zoom meeting an individual Zoom meeting where I can answer your questions. I have a lot of free time tomorrow. I'll be busy, but if you wanna meet up, I could schedule a Zoom meeting, no problem. Sound good?
Professor, did you say if we're starting the test right at 5:30?
Yep, right at 5. Well,
Okay.
I'm going to open up class at 5:30, and then we'll talk for a couple minutes, and then I'll make the exam visible. So, you'll have your full 2 hours, whether we start at 5:30 or 5:40.
Okay, perfect. Thank you.
Yep. And I will, yes, Atria, I will post this recording as soon as it's downloaded it and processed. I'll put it up on YouTube. Yep. Okay. And I'll try to post these notes too. I'm not sure if I've been doing that as well. I'll find all the notes that I've kept from classes and post those as well.
Professor?
Yep.
Can you give us another example of the fractional equation? Like how to balance it?
No, I'm not going to require you to balance anything with fractions.
Oh, okay.
You can if you want. You can balance any equation with fractions, right? I just am not going to specifically do that on purpose. That won't be my goal. Any other questions?
And then, sorry,
No.
the molecular formula is just, you have to write out the names, right?
Yeah,
Okay.
you would. Your best bet is to do it, writing it out and then put the formula down, right? Because that will help you not make the mistake of keeping a subscript that doesn't belong with something. So I would always, in fact, I might even tell you in the question, complete the following equation in words. I might just tell you to do it and not even give you the option.
Okay.
And then go through it step by step, just because I know at this stage of the game, it's super critical that you write the name first and then use the name to write the formula. Any other questions? All right. Don't forget.
Oh, no, sorry.
Last minute, you turned in there.
Sorry,
Yes.
last bit, sorry. So everything on the practice exam is, all the topics is going to be on the exam, right? Is there anything missing or?
I don't believe there's anything missing, and if I didn't put it on there, then it wouldn't be right for me to ask you. Although I don't recall, did I have questions about periodic trends on that practice exam?
Yeah, there's a bunch.
Okay, so yes, the periodic trends will be on there. Lewis dot structures will be on there. Writing and balancing equations, doing stoichiometry. So it's a lot of things, right? This is a pretty tough exam, but keep in mind the final exam, where this will be like half of the final exam. So you'll be really ready for the final exam.
Thank you.
All right.
So Dr. Hartmann, are you gonna like send us like the list of things we have to study like previous exam, or all is that all like in?
It's kind of brewed into the questions that I asked.
Oh, okay.
You want to look at those questions and see those topics that are covered. I think that's probably a safer bet.
Mm-hmm.
Okay.
Thank you.
Sure thing. And if you guys have a question, just email right there. You can always send an email, and I'll probably reply to everybody so that you all get the benefit. All right. Awesome seeing you guys, and I will see you on Thursday or before if you want to have a meeting. All right?
Good. Have a good one, Professor.
All right. See you guys.
Thank you. Bye.
Bye-bye.